Now let's look at an example where the initial velocity has an x and a y component. So let's look at the example of football. So let's say we have a football field here. All right, that's the ground. Let's put in a y-axis just for reference. So that way we can have an origin. All right, and so if we kick the football off at the origin, it's going to follow that parabolic path. Okay, let's say that it has an initial velocity, maybe it's 10 meters per second, and let's say the angle that it's kicked off at is 30 degrees. So can we now find how far horizontally that ball goes? Okay, so let's define a couple things here. So the initial position, 0 is there. The final position where it ends up is there. So how do we find the final position? So final position is the initial position, which on our coordinate system here is 0. So that plus the initial velocity in the x direction times the time interval. And then the next term is half the acceleration in the x direction times the time interval squared. But the acceleration in the x direction, remember, is always 0. So we're just left with this. So remember the initial velocity in the x direction, that component is the initial velocity times the cosine of the angle. So that's 10 meters per second times the cosine of 30 degrees. Cosine of 30 degrees is that 0.88 times 10 is 8.66 meters per second. Alright, so the final position is going to be 8.66 meters per second times the time interval. So how do we find the time interval? So again, the time is dependent upon gravity, the ball going up and then going back down. So we could say the final position is equal to the initial position plus the initial velocity in the y direction times the time interval plus half of the acceleration in the y direction, gravity, times the time interval squared. So our final position in the y direction, right, remember, is just down here, so we chose that to be 0. Likewise, we chose the initial position to also be 0 on our coordinate system. So these are both 0. Then the initial velocity in the y direction, how do we get that? Remember, it's the initial velocity times the sine of the angle. So that's our 10 meter per second times sine of 30 degrees is a nice even 0.5. So that means 5 meters per second is our initial velocity in the y direction. Alright, times the time interval plus 1/2 of gravity is 4.9 meters per second squared times the time interval squared. So let me factor out one of those time intervals here. So we'll have 5 meters per second plus 4.9 meters per second squared times one time interval there. The other time interval's here. So what does that mean? That means the time interval either has to be 0, right? Or it has to be, all right, we'll move the 5 meter per second to this side, that's -5 actually, equals 4.9 meters per second squared times the time interval. So we divide both sides by the 4.9 meters per second squared. And that gives us delta t is -5. So here the negative signs don't really mean anything because there's no negative in time. So 5 divided by 4.9 is 1.02 seconds. All right, So delta t is either 0 or 1.02 seconds. So both of them make sense though, right? Because initially, when the ball was here, at its initial position at kickoff, the time was equal to t equals 0. So that one makes sense. And then the other one at 1.02 seconds, that's where it is in its final position. So what we want to know is what's the time interval going from 0 to the final position. All right, so we'll plug that back in up here. The 8.66 meters per second times the time interval of 1.02 seconds. All right, our seconds will cancel out, and we're left with 8.66 times 1.02 meters, and it's about 8.8 meters is how far it traveled.